On July 1st, 2025, a faint, fast-moving point of light flickered through the Atlas survey pipeline, and within minutes the phone trees of half the world's observatories began to ring. 3I Atlas, an interstellar comet clocked near 124,000 miles per hour, inbound and slicing along the plane of our own planets. It would skim past Mars in early October, it would cross the Sun's neighborhood later that month, and it would do something no one was prepared for. It would arrive at the single worst moment to lose our best eyes. Before we go deeper, because this only gets stranger, make sure you're here for the recovery. Subscribe and set alerts. When the archives unlock, we'll post the astrometry, spectra, and brightness curves. The minute they drop, no hype, just receipts. The discovery record reads like a relay handoff. A network of ground telescopes flags the hyperbolic motion. The Minor Planet Center issues its circular within hours. Follow-ups confirm what the numbers already shout: unbound and interstellar. Veteran observers expect steep, random entry angles from the dark between stars. Instead, Atlas threads the ecliptic like a local, never straying more than 5 degrees from the flat, invisible lane where the planets circle. And then, just as the stage is set for Mars, the world's sharpest cameras blink. Silence. Perseverance's raw frames stop updating. The high-rise gallery posts only a shutdown notice. PDS mirrors show routine maintenance messages, with no obvious 3I Atlas entries. The timing is surgical. The shutdown begins hours before closest approach. Europe keeps going. Mars Express and Trace Gas Orbiter execute their plans, push operational bulletins, and post summary frames within days. Lower resolution than high-rise? Yes, but online. The contrast is stark. For the record keepers and the historians, a hole opens in the chain exactly where the chain should have been strongest. Even with orbiters and big glass pointed in, the imagery is a lesson in humility. The apparent cigar shape that ricocheted around headlines? Largely exposure smear. Integrate long enough to lift a 20th magnitude traveler from the noise, and its 55 kilometers per second motion draws its own silhouette across the detector. Push the stacks, and the nucleus stays unresolved. What you see is a diffuse envelope, a coma with signal-to-noise ratios skating the edge, background stars and cosmic ray hits fighting for attention. So the community pivots. Where shape won't show, spectra and polarimetry speak. Break the light into fingerprints. Measure how dust polarizes sunlight. Accept that integration time, the seconds or minutes it takes to collect enough photons, reveals the faint while blurring the fast. Claims get conservative. Priors get updated. The nucleus stays a rumor. The physics does not. The orbit, though that orbit won't behave like a coincidence. Oumuamua and 2I Borisov crashed the party from steep angles, quick through passes that matched expectations. 3I Atlas doesn't. It skims the ecliptic. It lines up a near-Mars pass in October, an Earth-favorable geometry in December, and Jupiter next spring. Monte Carlo mindsets caution. 3 ISOs is a tiny n, but dynamicists keep running the numbers, and the phrase vanishingly uncommon returns to the table. Mass estimates put the other outlier on the scales, to 33 billion metric tons. Pair that inertia with active outgassing, then try to find the usual orbital wobbles. The track barely flinches. If nature sends giants, where are the cousins? The missing pebbles problem bites. Detection biases account for some absences, but not the silence where thousands of smaller kin should glitter. The chemistry doesn't soothe nerves. KEK, VLT, and others log strong CN and CO comet classics, while the dust tilts silicate-rich, more like warmed rocky clays material than a pure deep freeze relic. Then the metallic whisper, nickel present in abundance, iron oddly shy. That inverts the usual meteorite-comet ratios. A few teams tentatively flag nickel carbonyl, like signatures lab plausible under extreme conditions, rare in nature at scale. On September 25th, the Sun throws a coronal mass ejection across Atlas's lane. Most comets flinch some fracture. Atlas's coma expands briefly, then stabilizes. No obvious fragments, no ragged spray. A measured adjustment and back to baseline, as if pressure found valves and stress bled through pores. Polarimetry adds an edge few expected. Early ground reports describe strong negative polarization light scattered in intensities, angles opposite to the norm for icy dust. Lab analogs that do this: spiky aggregates, hollow shells, metallic flakes, exotics. The implication is not proof of artifice. It is proof that, optically, Atlas's dust isn't playing by the usual rules. The shape remains a ghost, but indirect hints converge. An elongated form, possibly kilometers long, with a length ratio width that looks engineered for interstellar travel, minimizing cross-section, dampening radiation exposure. Pair that with orbit stability and storm resilience, and speculation finds fresh oxygen. 3 hypotheses make the short list. 1. Trojan horse probe. Mostly natural body, subtle deviations, perfect camouflage for a long-duration scout. The ecliptic hugging corridor, multi-planet choreography, and storm poise feed the case. The missing piece? A technological signature: radio, thermal waste, structured maneuvers. Extraordinary claims still demand extraordinary receipts. 2. Planetary seed. Massive objects can be ejected from young systems, roam the interstellar, and if a star captures them, serve as planet-building nuclei. The chemistry and scale fit pieces of this. The mechanism and statistics? Under debate. 3. Extreme natural comet. Conservative anchor. Fold all anomalies into the long tail of comet behavior. Uncommon doesn't mean impossible, but every new inconsistency forces another asterisk, and the asterisks are multiplying. Underneath the labels, the risk math stays cold. Even at comfortable distances, 33 billion-ton body, traveling interstellar fast, carries kinetic energy beyond any human machine. Fragments, should they appear, could be mountain class. Nobody forecasts fiery headlines. Everybody watches the data for trajectory changes, outbursts, fragment trains, and photometric spikes that would hint at stress. Return to the blackout that started this cascade. Was it malice? Bureaucracy? Bad luck with surgical timing? A government shutdown flips non-essential switches to off. Targeting requests that would have retasked MRO for deep space frames never go through. Teams that could have shepherded opportunistic imaging are ordered home. ESA continues on plan, posts what it has. Scientific truth lives in this contrast. We needed both. High-fidelity US views plus European continuity would have closed the loop stayed open. So how do we decide cleanly, publicly, what 3I Atlas is? We set tests no narrative can wriggle past. Test 1. Orbit residuals. After conjunction and perihelion, reacquire and fit. If outgassing alone explains the path, residuals look like noise. A step a sudden offset beyond what jet models allow signals an impulse worth investigating. Test 2. Morphology. Classic anti-solar tail should reassert. A persistent sun-facing collimated jet, especially one that doesn't behave like an anti-tail dust sheet, demands replication or refutation. Test 3. Spectra. Do swan bands C2 appear? Do CN-CO H2O ratios shift post-heating and post-storm? If green imaging persists without C2, we chase alternative fluorescers or dust luminescence physics. Test 4. Polarimetry and phase curves. Does the negative type polarization persist, and at what phase angles? That curved fingerprint surface, dust microphysics no image can fake. Test 5. Companions. If previously reported companions persist with near constant spacings, formation behavior rises. If they diverge at rates, they're debris. While we wait, one more wrinkle. JUICE Europe's Jupiter Icy Moons Explorer has a window to catch Atlas, with its cameras and spectrometers, late November 2025, from a geometry no Earth orbiter can match. The downlink lag is brutal, the vantage is priceless. If those datasets land, we'll see the cross-checks this story deserves. Let's stitch the narrative cleanly, then. Discovery. Hyperbolic, 55 kilometers per second, low inclination, retrograde interstellar and ecliptic hugging. Mars flyby, Oct 3-4, US. Public feeds go dark under shutdown. ESA maintains continuity with lower res sets. Chemistry and dust, CN-CO robust, silicate strong. Unusual negative polarization. CME encounter, SEP25, controlled coma expansion, then stable no obvious fragmentation. Perihelion peak heating, object behind the sun, only indirect monitors. Astrometry, spectra, morphology checks. With that map, the blackout stops being a conspiracy and starts being what it was: a wound in the record sown by policy at the worst possible time. The scientific response is the antidote: redundant data paths, cross-agency cooperation, pre-approved grab-and-go target templates for the next ISO. Where does that leave the engineered question? On the table, but surrounded by rulers and calipers, not headlines. If the outbound orbit shows a step no jet noise model can carry, if morphology refuses radiation pressure, if polarization stays exotic and companions hold formation while the whole ensemble slides through space, then we escalate. We design campaigns for radar if geometry allows, for deep IR if glow exists, for radio if anyone's whispering. And if the numbers hold? If Atlas exits with nothing but a ledger of rares stacked atop rares, then we file it under nature's long tail, update our priors, and teach the next generation that the galaxy's export catalog is wider than we thought. Either way, we win if we measure. So here's the plan you'll see on this channel when the sky reopens. 1. Side-by-side astrometry, predicted versus measured track, call the residuals. 2. Photometry, same apertures divided by filters, night over night. A spike equals outburst, flatline at peak heat equals its own anomaly. 3. Spectra, high SN on C2CN, CO, H2O bands. Post-perihelion shifts map directly onto pre-perihelion baselines. 4. Polarization, phase angle sweep, rerun the curve. 5. Companions, separation curves, fragments diverge, formations don't. If you want those plots without the noise, you know what to do. Until then, hold two truths. First, 3I Atlas is the most geometrically peculiar, chemically uncooperative, and optically disobedient interstellar object we've put under a lens, and we missed a critical close-up because our systems weren't ready to image during a shutdown. Second, none of that settles the question. Only the December numbers do. Watch the orbit residuals. Watch the tail, watch the spectra. And remember, the cosmos does not care how neat our categories look in a lecture. It sends what it sends. It tests our tools, our models, and our patience. So, what do you think 3I Atlas truly is? If you want the real answer when the data arrives, like to support our search, share with a fellow space enthusiast, subscribe for the analysis the moment it's live. The sky will decide. Will you be watching?